Are there really life on other planets? And if there is, what life is there? What are black holes? Are they a gateway to another galaxy? Another time? Is that the answer to time travel? Well, today we have astronomer, professor, and author, Father Kurt Messick, on the show to talk about all these questions about the universe, the galaxies, the constellations, what they meant to our past, and what they mean for our future. I'm Tony Sweet with Truth Be Told. Please welcome to the Truth Be Told studios for the first time, the one and only astronomer, author, Father Kurt Messick. Kurt, how you doing?
Doing well. How are you?
Well, I'm doing well, but I'm here in Southern California where it's chilly for us at 60, almost 70 degrees, but you're up in Iceland. What are you doing up there?
Well, I come up to Iceland quite frequently. My father was stationed here when I was a child, and I fell in love with the place. Once upon a time, the airport used to be a big NATO base during the Cold War, and it was converted into a big international airport sometime in the 70s, 80s to connect for low fares North America with Europe, if you didn't mind stopping over 2 or 3 times.
Right.
But I have a lot of friends here, and the geography is really fascinating here too. There's on our planet, most people know there's something called the Mid-Atlantic Rift, which is where the plates are pulling apart. Well, that extends almost all the way from the southern ocean, just off of the coast of Antarctica, all the way up to the North Pole, and it's underwater the entire place, or the entire length of the ocean, except for Iceland. That's where it's above ground.
Really?
So you can literally stand with 1 foot in Europe and 1 foot in North America, and the plates are separating out. And that's where you get earthquakes. That's where you get volcanoes.
Right.
That's where you get sets for Game of Thrones. All sorts of
right. Well, I always found it fascinating, and for the people that are watching and listening, we'll get into the astronomy part here in a minute, but I always found it fascinating when they say Iceland and Greenland. It's almost completely opposite.
Yeah, the old mythology is it's more of a legend than true that Greenland was called Greenland to try to entice people over.
to come over. Yeah, come on over.
And Iceland was called Iceland to discourage people from coming over. But the truth is, the southern tip of Greenland and the southern half or southern third of Iceland are all pretty green. If you think of Ireland,
right?
Ireland is actually fed by the same environment as the south coast of Iceland and the southern tip of Greenland. The Gulf Stream takes warm water and warm air. So I teach in Indiana at Ivy Tech Community College in Indiana. It is often colder in Indiana than it is in Iceland.
Wow. Well, right now it's my dad and family live in Kansas, and it was pretty dang cold there today. There was getting snow and ice. So
yeah, see, that's that mid-continental weather. If you're near the coast, then you get a lot of mitigated temperatures and a much less diverse in temperature wise the environment. You get hurricanes and tsunamis and other kinds of things like that. So it's a trade-off.
Well, California, we don't get much hurricanes here at all, or tsunamis, but
but you get earthquakes. So
true.
So
that is true. Yeah, we haven't had. Well, we just had one the other day, but here, a 2.9 is like, oh yeah, whatever. Next, a lot of people don't get to travel to Iceland, Greenland, all these closer to the Arctic Circle or the Antarctic, but especially the Arctic Circle with climate change or whatever you want to call it, global warming. Have you noticed a difference from when you were younger in your childhood until now, how Iceland is changing at all?
It is changing, and the largest thing that's changing in Iceland is the receding of the glaciers. They are melting,
Right.
and they are sort of scaling back. There's a combination of different factors for climate change, though, and what we often think of when people say the words climate change, they're usually thinking Al Gore, inconvenient truth,
Right.
all that sort of stuff. The truth is the climate has been changing on our planet for billions of years, and we've gone into ice ages, and we've gone into warming spells,
right.
And that's you can see that in the terrain in Iceland as well. The changes over tens of thousands of years, not just in the last 50. So there, I think there's cause for concern, but not alarm. I'm not an alarmist. I think there are things we can do to make things better. But I don't see us turning into Waterworld, for example.
Right. Well, it was one of the biggest
Exxon
flops.
Valdez has been retired, so we don't need that.
Right. I was going to say that was a big flop for as much money as they put into it. So
it was. But there's a moon. I always thought if they need a sequel for that, there's a moon around Jupiter that is literally a water world.
Really?
It's frozen over. It's called Europa. And I thought we should send Kevin Costner there to film the sequel.
Well, actually, I have to say, I did interview somebody from NASA several years ago, and he told me about all these different planets, and we're going to talk about all this stuff, but all these different planets that were like of water and just other, and I'm like, what? I mean, it was hard to believe that there's certain planets out there that are made up of solid whatever, gold or diamonds or whatever it was. It wasn't maybe not that extreme, but it was just to the point where you're like, that seems so unreal. Yeah, that's pretty interesting. Well, it's your first time on Truth Be Told. Could you, there's a whole list even under your name: an astronomy professor, a chaplain, what is your background and how did you get involved in what you're doing now?
Well, anyone who's my age who is an astronomer in any sense of the word, and there are different ways of being an astronomer, probably is that because of Carl Sagan. Neil deGrasse Tyson, the most famous astronomer on the planet right now, I think, and I are about the same age, and we were attracted to it by the same mechanism, Carl Sagan's cosmos. And I diverted away from astronomy for a while to go into a political career. I was fortunate enough to work for Margaret Thatcher in England back in the 80s, and worked on Capitol Hill for Senator Lugar for a while. I then started getting involved in my church, which is the Anglican, the Episcopal Church, and went to seminary, and that's how I became Father Kurt. So I'm holier than thou, but not really. And but then as I started doing things with that, I became a professor of philosophy and religious studies at a place called the American Military University, and they gave me free classes. So I went back to start studying astronomy again, and ended up being offered a teaching position in astronomy here in Bloomington, Indiana, which is where I started out at the community college. So I sort of went full circle by doing a bunch of things in between. Somewhere in the middle there, I was also a stand-up comic for about 5 years. So if I'm making something that sounds like a joke, it's supposed to be, and if it's not funny, now you know why I'm not a comedian.
Right. That's hilarious that you went from these very serious scientific and professor-like to a stand-up comic. Was that something just to break out of your comfort zone? Is that
partly, but also I thought it would help making sermons and help making lectures lot better, and be able to connect to the people. And I really think that my ultimate payoff for myself is that I do get awards and other kinds of things for being able to connect to people, rather than standing up there and giving death by PowerPoint.
Right.
Some people just sort of read the PowerPoint. It's like, what's the point? You can just hand it out.
Right.
And I tell my students that I'm not going to read the PowerPoint to them because I'm dyslexic. I don't know how to read anyway. You ever see a guy named Sid Lexic on the online gaming? That's probably me.
That's probably, oh, okay. Well, I'll be watching because I like to game myself. Well, as we know, ancient, Egypt and many ancient civilizations, they used the stars. They used, the the constellations and many things to kind of live their lives, building their sites and crops, and pretty much everything about their lives were really revolving around the stars. So man, as we know it, have been looking at the stars in wonder for millions of years, at least tens of thousands of years, hundreds of thousands of years. How important?
I'd say millions of years is an accurate thing.
Well,
we don't have writing from back then, but we do have a little bit of evidence here and there that tells us they were noticing the sky.
Well, that's my take on it too. But you know how people there's no people around that long ago, but there are evidence now that at least 25 to 30,000 years ago that there was civilization. So, but now that we have all this technology, why do we still need the stars, and why are we still seeking more information about the stars and about our past and even our future? Why is it so important?
Well, people have been, as you mentioned, looking at the stars and trying to figure out what they are, what meaning they have for us, if any.
Right.
Since before people could read and write. Stonehenge was constructed by people who didn't have a literate society. The people in Britain at that time knew how to orient the stones to tell the cycles of the year without being able to write. And there are cave paintings in the south of France that date back literally 20,000 years, 18,000 BC, that show in the cave art the progression of the progression of the lunar phases, the orientation of the pyramids and others. We live inside a giant clock, essentially. The sun tells us how the day goes, the moon tells us how the months go, and the sun tells us how the year goes, along with the constellations. So we're really living in something that repeats over and over again. And people began to notice that life is pretty cyclical. The universe is pretty cyclical. Maybe there's something religious or philosophical to that. And they began to put meaning from their own lives into what they were seeing in the sky. And to help learn the sky, we have today officially 88 constellations. The International Astronomical Union puts the sky into a big map, sort of like a globe inside out.
Right.
And there are 88 constellations. If anyone plays the piano, just remember 88 keys on the piano, 88 constellations in the sky. And but other peoples, other cultures have had other designations. Like the Big Dipper can sometimes be the Big Plow or the Big Cup, or the Big Bear, Ursa Major. One of the fascinating things about Ursa Major, the Big Bear, is that Asian cultures and Native American cultures both looked at that and saw a bear without contacting each other.
Which is fascinating.
But we think that, in fact, that was an ancient historical memory that was brought over whenever they came over, and there are different theories about when they came over, but that they remembered that, and that stayed in the sky with them wherever they went in the northern hemisphere. Of course, by the time they got down into the Andes, the Incans and others, they couldn't see the Big Dipper. They couldn't see the Little Dipper. It's too far over the edge of the Earth. So, which is another way we know the Earth is not flat, and the way that the ancients knew the world was not flat. So understanding just where we are in the world. Part of Carl Sagan's Cosmos has the story of Eratosthenes, who figured out that there's a place in Egypt called Syene, where on the longest day of the year, there are no shadows. The sun goes directly down the well. But at his home, several hundred miles north, on the longest day, there were shadows. Why is that? Because the world is curved. And he actually figured out how large the world was. Now, fast forward 1,500 years from there, and we get to a guy named Columbus. He knew how large the world was based on what Eratosthenes had done, and lied to Queen Isabella because he knew if he told her the truth, she wouldn't fund his enterprise to go across the ocean with ships. So lying to get grant funding has a long established history in science.
Wow, that's pretty fascinating, though, because it is true. And I was talking to Scott Walter, Scott Walter,
Yes.
forensic. So we were talking about, a lot of these pyramids and certain things that were built from the constellations. But is it true that, now that maybe 1,000 years, 2,000 years has gone by, the Earth has slightly tilted? So what they saw in, let's say, at noon once a year, the sun would shine at this certain spot, is not accurate now. Is that correct?
That is correct. That's if you remember a scene in the Indiana Jones and the Last Crusade movie,
right,
where he's in the map room and he has the crystal that goes, and they're like, oh, the Nazis are digging in the wrong spot. Well, Indiana Jones would have been in the wrong spot too, because
that's what I thought.
There's something called precession. Our planet is tilted right now towards Polaris, and pole, Eris means North Star, pole for pole, and Eris means star. And we're tilted at 23.5 degrees towards Polaris. But we're not always tilted at that angle, and we're not always tilted in that direction, because we have something called precession, and you're showing that here. Our Earth wobbles about once every 26,000 years in a full circle. So 13,000 years from now, and 13,000 years ago, we were and will be pointed at the star Vega. That will be the North Star. And the North Star changes based on our wobble. So 5,000 years ago or so, when they were building the pyramids, we were almost a quarter of the way, maybe 20% of the way around this circle. And so we had a different North Star, and we had different orientation in that regard. That has implications today, because if you think you know what your sun sign is, your zodiac sign, you're looking up in your horoscope and says, I'm a Libra, I should stay in bed today and binge Netflix and eat mint chocolate chip ice cream. By the way, if my horoscope ever says that, I'm converting. That's right. What it was. But the thing is, almost everyone is wrong with what they think their sun sign is, because those signs were set up by the data in a book by a guy named Ptolemy, who wrote a book called the Almagest. And Almagest essentially means big book. So he wrote the big book about where all the stars are. And he wrote that book almost 2,000 years ago, maybe 1,600 years ago, based on information that was already, when he was writing it, 1,000 years old. So the information on where the stars are that most astrologers use is 2,600 years out of date. We've shifted an entire month out. So if you think you know what you are, you're wrong.
I mean, that actually is fascinating, because I've had many astrologers on my show, and they've done readings, and especially like ancient, I think Chinese in Kabbalah astrology, these are thousands of years old, or 1,000 years old at least. So definitely that's not going to be as accurate.
Well, if they're basing it on a philosophy of how stars might influence you,
right,
to a certain extent, it doesn't really matter where in the sky they are. It's a religion, not a science. If they're trying to make it into a science, they're going to fail in the way that a lot of people in a lot of religions who try to force something into it, like, I've found evidence of the Great Flood. It's like, no, you didn't. You found evidence of a flood somewhere at some time. You didn't find evidence. But yeah, I mean, the thing is, there's in the ancient world, science, religion, philosophy, all these things were not separated out. And today they are, but sometimes when people try to mash them together inappropriately, it's sort of like taking Legos that are the wrong size and thinking you're going to build something stable.
Right.
I love Legos, so I know that doesn't work. You have to have them all the same size, the same briquettes. Because if you try to use the big ones and the small ones, everything falls apart.
Right.
That's what happens with so much of science and theology in all of the religions, not just Christianity or anything else. But part of the preservation of science over time actually comes from religious ideas. Most of the stars that we have in the sky today have been cataloged by people for thousands of years, but some of the greatest catalogers were actually the Muslim catalogers in the golden age of Islamic astronomy in the couple of generations after the time of Muhammad. And it had a very practical reason for doing that, the culture did. If you're going to pray as a Muslim, one thing that you are expected to do is face Mecca. Well, how do you know where Mecca is if it's over the horizon, especially if it's hundreds or thousands of miles away? One of the best ways to do that is to figure out what stars will be over Mecca. And so the idea of cataloging the stars, figuring out how to trace where you are based on that, became very important. Those catalogs were brought into Europe during the Renaissance, and a lot of the star names we have to this day owe their naming, including Vega, including any star with the beginning AL, like Altair or Alniz, and even Betelgeuse. Betelgeuse is a name for a star that is a corruption of a Muslim name from a catalog that we kept.
And then it became a movie.
And then it became a movie. Yeah. I tell my students, I go outside every night, especially in the winter, we can see Orion. It's part of the Orion constellation.
Right.
And I yell up at the sky and I say, Michael Keaton, Michael Keaton, Michael Keaton. because Betelgeuse is the most likely star in our sky to explode at any given moment.
And then you hear, I am Batman.
Well, in space, no one can hear you say Batman.
Right.
From Sigourney Weaver.
Well, let me ask you this, because you were saying that a lot of this is the ancient astrology is not really accurate. So, what about if stars and such as the moon can affect our tides?
Yes.
So how can it affect our tides, which is part of the Earth, which is an energy, which is and we are energy. So how can the moon or stars not affect us, or can they? In your words.
Depends upon what you mean by affect. That's one of the key things to keep in mind. The moon, the moon does affect us gravitationally. That's what's pulling on the water, in large part because it is so close.
Okay.
It's 250,000 miles away, more or less. And the closer you are to something, the more gravitationally attractive you are. That's a basic Newtonian principle. All things, it doesn't seem this way at the end of the night at the bar, but all things are attracted to all other things. And the closer you are and the bigger you are, the more attractive you are. That also doesn't work in the bars.
I've tried that many times. It doesn't.
Well, in my pre-priestly days, yes. But never mind. We won't talk about that.
Right. That's next time.
But the further away you are, the less influence you have gravitationally, and it falls off what's called the inverse square rule. If you're twice as far away, you're only 1/4 as attractive. If you're 3 times as far away, you're 1/9 as attractive. If you're 10 times further away, you're only 1/100th as attractive. So you see the influence falls off very, very quickly. Well, the stars are literally millions and millions of times further away. So the chances of them actually having any kind of influence at all is vanishingly small in terms of gravity. And we know that gravity and electromagnetic radiation is also governed by the inverse square rule. You're not getting much that's there. So essentially, you can let yourself be guided by the ideas of what you're supposed to be. Well, I'm a Libra, so I should be well balanced. Well, I was born under the old classification of when a Libra is. I can tell you that is not true. So something went wrong with the scales when I was born. That's there, and again, it's the idea of religiosity that how is it influencing you? The reason why there are more people in emergency rooms during a full moon is very simple. There's more light on a full moon night than there is on any other night. And if you watch the progression, you'll see there are more people in emergency rooms when it's sort of 3/4 moon, a gibbous moon. and very few during a new moon when there's no light at all.
Right.
We're still guided by the moon phases. There's this idea, say World War II, when we were going to invade D-Day in France, that the Germans didn't know when we were coming. Right. The truth is, the Germans knew that there were only 3 or 4 days we were coming, and it was going to be on the new moon of May, June, July, or August. It was not going to be any sooner, and it was not going to be any later because the weather wasn't going to be around. And you didn't want the moon causing a reflection on any of the ships and transports that were coming across the channel. So we were still being governed by the moon to do things there.
Wow, look at, man, you have a lot of knowledge in that head there. I love it.
I do these lectures a lot, so I've got
so you're like, I got this down. You know, I'm going to go directly into the stars. You know, you've had the chance of interviewing William Shatner, which one day I hope I get to. So congratulations on that. So we're going to go to the, you know, the land beyond the stars. So many of the stars we see in the sky, I mean, there's billions, trillions of stars up there, but is it true that many of them are already dead stars and it's just so far away that the light has not burned out? Is that true?
That is very true. Yes. Because if a star is, say, 2 billion light years away, and there are some that will be that far away, and it only lasted the star 1 billion years, that means that we are seeing light and the star is already gone.
That's
fascinating.
The star is already
dead. Most of the stars that we're seeing, though, with the naked eye, with the unaided eye, are in our own galaxy and relatively close. So the dead star idea is vanishingly small in terms of how many we would be actually seeing with regards to what we ourselves see. On the other hand, Betelgeuse, which is a couple of thousand light years away, if it had blown up 50 years ago, we wouldn't know for another couple of thousand years. It will take that long to get to us. The sun is 8 light minutes away. If the sun blew up 7 minutes ago, we wouldn't know for another minute, which is not exactly a reassuring idea.
No, yeah. We wouldn't really have much of a chance to.
No, and if we have space probes around the sun. So one of my students said, well, why don't we just put a probe to let us know ahead of time? And the thing is, the light would have to go from the sun to the probe, and then it would take the same amount of time to go from the probe to us. So all the probe would be telling us is, oh, we're sorry, you're dead now.
You're dead, right? Yeah, so, I find that fascinating because, you know, even on Earth itself, we've been here for so long, and we're always doing, you know, like people like you're doing research, and we have people in Egyptologists, you know, archaeologists digging all the time, finding new information, and we find new information all the time about stuff on our planet, and we are, you know, it's a big planet for one person. But for the universe, we're just a speck on a speck on a speck on a speck on a speck. So I just find it fascinating how much information about our existence is out there that we'll probably never find in 1,000 lifetimes. But how close are we, do you think, of finding more information about life on other planets? As we call on Truth Be Told, and many of our, you know, aliens that come to this Earth or don't come to this Earth. How far out do you think we are to actually finding more of that out? I mean, like I told you, I've interviewed, you know, people from NASA and talking about different planets, and he believes every year there's planets out there that can sustain life. We just don't. They're so far out, we just can't go visit. But in your opinion, what do you think about the next step in our space travel?
Well, the history of astronomy has been making the universe larger and larger and larger.
Right.
If you go back to Ptolemy, the guy who wrote the charts that astronomy and astrology used for a long time, the Earth was in the middle, and everything was going around us, and we were sort of inside a globe of stars.
Mm-hmm.
Then Copernicus came along, and it's a little more complicated than that, but basically Copernicus came along and put the sun in the middle and put the stars much further away. So the universe suddenly got a lot bigger. And then Galileo and Kepler and Newton pushed them out even further, and it got even bigger. And then in the early 1900s, we found out that the galaxy was not all there is. There are other galaxies, and the universe just got bigger. And we just sort of keep going and going and going like that. So the history has been that the universe keeps getting bigger, but we also keep figuring out ways to discover it and study it. And it gets more and more understood in a lot of basic ways. And just in the last 50 years, when I was studying as an undergrad, we had one sentence in one book that said, maybe someday we'll find out that there are planets around other stars. We didn't know any of them. This was the 1980s. First exoplanet, planet outside of our solar system, was discovered and confirmed in 1995. And since then, we've found thousands and thousands of them. And not only that, we found Earth-like planets, we found Jupiter-like planets, we found hot Jupiters, which shouldn't be where they are. We found some with atmospheres like the Earth. We found some, as you were mentioning before, that seem to be completely made out of carbon, which if they're carbon and they're crystal means they're diamond planets. 51 Pegasi, 51. The way we've discovered that one, and the way we've discovered a lot of them, is by what we sort of see as gravitational tugs and pulls. We don't see the planet itself, but we see the gravitational effect it has on the star that it's going around. And this first planet that we discovered goes around its star so fast, it goes around in about 4 days.
Oh my God.
So the star is sort of wobbling back and forth. And once we had sensors and detectors that were sensitive enough to register that wobble, we could tell that that was happening. Sometimes we're lucky enough to see them edge on. So we see actually the planet go in front and behind. That's called a transit and eclipse. And that will dim the light on the star. And also, if it's right in front, we can take a reading of the light coming through the atmosphere towards us and tell what's in the atmosphere. And that's how we've come to understand that there are a lot more Earth-like planets. But beyond that, when I was, again, an undergraduate, we had the idea, well, maybe Mars had life once upon a time. Essentially nowhere else in the solar system is habitable. Last year or the year before, I think it was Sky and Telescope magazine had an article, the top 10 places in the solar system, in this solar system, likely to have life. And Mars and Europa, the moon I mentioned before, where Kevin Costner can do the sequel, are tied for top place. But Pluto made the top 10 list for where life might be. And it's fascinating that you can be that far away and essentially frozen, and yet there's enough energy inside of Pluto to keep things from freezing solid. And the three things you need for life are carbon, at least as far as we define life right now. Carbon, energy, and a liquid. And if you know there's carbon on Pluto, we've been there, we've taken the readings. We know there's liquid stuff, and there's got to be energy to keep it liquid. You've got the three things you need. Titan, which is a moon of Saturn. We've actually landed on Titan. We sent the Cassini probe up, and it was in orbit for about a decade and a half of Saturn. Well, it took a backpack along called Huygens, and it dropped it off on the moon. So we've actually landed on the moon of Saturn called Titan. And we found falls and lakes and rain and clouds, but they were all methane. They weren't H2O. But methane has carbon in it. So now we have liquid, carbon, and energy. So we may have creepy crawlies going around on Titan. So one of the hoped for NASA projects in the next couple of decades, now that we can do drones on other planets, we've done that with Mars, is to send drones to Titan and explore around there. And I just hope we'll be able to do that. But there's so many possibilities.
Yeah, I find that all fascinating. And like you said, we're trying to find like Mars and different planets, and I'm excited. I too one day find that planet even beyond our solar system that does have. Because when we say life on another planet, well, that, like you said, that could be like just a small molecule or something that's alive.
Mhm.
But most of us think life on planets as creatures like ourselves that are intelligent and Mars dog or something. That
Or people who can radio in. Yeah,
right,
that's the big Drake equation thing. And
right,
if you haven't heard of the Drake equation, that's the calculation for the likelihood of other places in the universe to have life. And when it was first formulated, really the only thing we could say is how many stars there are. The variables in this include how many stars there are, how many planets are around those stars, how many of those planets are in the habitable zone, which is where everything doesn't freeze over.
right,
How many of those habitable zone planets will actually develop life? How many of those will develop complex life? So you get away from bacteria and into things that can move around and build log cabins. How many of those log cabin people will actually build radio telescopes? Because see, if aliens were trying to contact us 200 years ago, I mean, George Washington was a smart guy, but he didn't have a radio to tune
right.
in. Julius Caesar 2,000 years ago, it's like, okay, it's like, yeah, we were uncontactable. So it wasn't that we weren't civilized or didn't have a civilization or didn't have intelligence. We just didn't have technology. Well, what we figured out is a couple of things about that equation. One, we know that pretty much every star and sometimes star clusters have planets. Lots of those planets are in habitable zones, but we don't have to just stick to the habitable zones. Pluto is not in the habitable zone in our solar system. Europa, Titan, they are not in the habitable zone in this solar system, and they could have life. So we're having to revise that as well. And given that there are upwards of 400 billion stars just in our galaxy, and
Right.
then there are hundreds of billions of galaxies, and all of them may have 8 or 9 planets and be debating whether one of them is Pluto and not a planet on their own planet.
Right.
There could be lots and lots of places out there. The other side of that is, how long does the civilization last? Because if we last as a radio communicating civilization for about 2,000 years and then for whatever reason go extinct, then that's a very small window in the billions and billions of years
Right.
for anyone to find out that we're here.
Exactly.
It's like watching your favorite sitcom and then they cancel it on a cliffhanger after season 1 and you're like, no, I was
they've
interested.
done that. Netflix did that to me on one show. I was like so pissed off. I was like, no.
Networks were doing that to me back in the 70s, and I'm like,
right. Yeah,
I go back and I find them on YouTube, and I still get that same irritation.
Right,
It's
you're like,
why didn't you finish this story?
It's like I can't even finish the last episode, and I don't want to watch because I know it's gonna leave me on the cliffhanger. Because of time, we have about 10 minutes left, and I'm enjoying this. By the way, you are so fascinating, and definitely you'll have to have a part 2. But
that will end on a cliffhanger. Yes.
Yeah, right, and then never have you back. No, I was kidding. But as most people can see behind me, if you're watching the YouTube channel, you can see it. But if you're watching the podcast, it's actually a picture of a black hole. I always find black holes fascinating because, first of all, what is it? Is it a wormhole? Where in the hell does this go? I mean, it's hard to believe it just goes into blackness, but it's like that's a destination. If it's just blackness and there's nothing light, nothing can live in there, so it's still a destination. So first of all, what is a black hole?
Well, a black hole is one of the ways in which a star ultimately dies. And there are 3 main ways that a star can die, depending upon how large the star is.
Right.
If it's a smallish star, it'll eventually turn into what's called a white dwarf. It will sort of puff out its outer shells, become this lovely planetary nebula. If it's a mid-range star, it will sort of really explode out and turn into a supernova splat, but it'll form what's called a neutron star, where the material inside is compressed into such a high density that you'll have as much as the entire sun compressed into something the size of Lansing, Michigan. So sort of one bucket, one like sand bucket of the material would weigh as much as an entire continent or more.
Right.
But then if you get above a certain amount of mass, 8, 10, 12 solar masses, the way the star dies, again, it has the supernova explosion, but most of the rest of the material will compress, and nothing can stop that compression because the energy inside the star is no longer generating. And it will just go down to what's called a singularity, which is a simple mathematical point. It has no dimensions. It's not width, not length, not height, nothing there, but it still has mass. And so it's still pulling things in gravitationally. And the picture that you have behind you, the sort of artist rendering there, is showing the material spinning into the black hole. You can't see the actual black hole. You can see the effects that it's having around you. And because the thing itself won't let anything, including light, escape. Because you'd have to go faster than the speed of light to outrun the gravity if you're at the point of singularity or anywhere around it. And that area around it becomes larger and larger depending upon how much mass is in the middle. So that's where people think there might be wormhole ideas, in that area between the boundary, which we call the event horizon, and the singularity at the very center. What happens inside there between those two? We really don't know. Even mathematically, we don't know, because the equations all start doing weird things. And like in math, they always tell you don't divide by zero. You can't divide by zero. Well, when you're doing the math on these things, they all divide by zero, and it's like no, that can't work. So early ideas, Einstein and another guy named Rosen came up with things called the Einstein-Rosen bridge, where one black hole might link to another black hole at some other place in space-time. Remember, we live in 4-dimensional space, not 3-dimensional space, because we've got time as well. And so it could link there, and then, so theoretically, they use this as a theme in Star Trek once and a few other places. But you could enter the black hole through the event horizon and exit the other side. Now, no one can ever explain how you can exit the other side, because that's also a black hole, and it will also keep you trapped inside. So you may end up on the other side of the universe just to be trapped inside, and you can only look. But then you can't get back out on your own side because the door is locked behind you, and that's no fun. I've done that before. I locked myself out on the roof of my college once, and it's like, okay, how do I escape this? Yes.
Help! Nobody's paying attention, and
I was there on a day everyone else was off. It was
God!
So it's like, okay, yeah, this is not fun. Have me back, I'll tell you that story. But black holes actually do have one thing that they do emit, and that's where Stephen Hawking got his probably greatest claim to fame. There's something called Hawking radiation, and Hawking radiation is these particles that pop in and out of existence, and they're doing that everywhere in the universe all the time. But if they do it and they cancel each other out, a proton and an antiproton, matter and antimatter, canceling each other out. But if they do it right on the event horizon and one falls in and then one escapes, then that takes a little bit, tiny bit of the black hole's overall energy away from it. And so black holes are on the order of trillions and trillions of years. I'll embrace my inner Carl Sagan. It's trillions and trillions of years. They're actually evaporating.
Wow.
So black hole evaporation is a weird thing, but it is a thing. But there's so much that we don't know about it still, because, and we didn't even know whether they were real things until fairly recently. They were just theoretical things. One of the best books, I'm going to plug my friend here, her name is Marcia Bartusiak, and she wrote a book called Black Hole. And the subtitle is How an Idea Abandoned by Newtonians, Hated by Einstein, and Gambled on by Hawking Became Loved. It's a great book, and it doesn't have a lot of equations, so don't be afraid of the math. But it talks about the history of the idea of the black hole and how we began to discover what's out there around it.
Well, I mean, do you believe, like you said, and just to finish this out, black holes, portals, could this answer a lot of questions to time travel?
It could, because again, we're living in a four-dimensional, at least a four-dimensional
Right.
place. We're interacting. We interact almost completely in three dimensions, up, down, side to side, and all of that. We do not interact completely in the fourth dimension. We're from our perspective, from what we're doing, we're sort of locked in one direction. But when you play with the equations around a black hole, at the event horizon, time stops.
Mm-hmm. Wow.
So if you go beyond the event horizon, does time go backwards?
That's
What's happening there?
Interesting.
And we know gravitational fields interfere with the passage of time. The GPS satellites that are above us right now are actually operating on a different time frame of reference than GPS receptors here on the ground, because just being a couple of 100 miles away from the surface of the Earth,
is it slower up there?
Gives them a different thing. The closer you are to the gravity, the slower you go.
Yeah, that's what I figured.
So they're actually operating just a little bit faster, and we have to adjust their clocks so that they don't make us all drive off of bridges. Or maybe that's what they're planning. But that's
I was going to say
movie, so that's another.
Yeah, that's Terminator. Well, the last thing I want to ask is, with all this information we've talked about today, and we've talked about life on other planets, what is your take on, and especially adding the religion into it, on aliens? Do you believe that aliens have that technology? Do you believe that aliens exist at all? Do you believe they've helped, because people are like, how did they build the pyramids? How did they, it's like all these unknown things of technology that we don't even have today that could build something of that magnitude. What is your thoughts on extraterrestrials?
Well, I will say I firmly believe the Egyptians built the pyramids on their own, and ancient cultures were probably smarter than we give them credit for in a lot of ways, because just because we've lost their techniques doesn't mean they didn't have them.
Right.
I think there are a lot of people who can't dial old-fashioned telephones because they don't know how anymore.
Right.
They haven't had to. That doesn't mean that aliens came down and taught the people who are around, although that technology does seem rather alien to us today.
Right.
But I do believe, and there's a researcher named Seth Shostak, and he has been seeking funding for SETI projects, Search for Extraterrestrial Intelligence, for several decades now, and with some success. So he's done a lot of surveys that are out there looking for signals. We haven't found any, but again, space is so vast and time is so vast that it becomes an issue of not just looking, but looking at the right place at the right time. And there's so many places to look. So I'm convinced if anyone was looking for us, they won't find us in terms of radio signals or television shows for hundreds, if not thousands of years. And that's just our little corner of the galaxy. They wouldn't be able to find the old I Love Lucy reruns or heaven forbid the old Jersey Shore reruns for another 100,000 years on the other side of our own galaxy.
But I Love Lucy will still be good, though.
I think it will be. Yes. And Jersey Shore will. Well, never mind.
Yeah, we'll leave it that one.
Yeah, it's like there's no intelligent life there.
No.
But no, I believe that there is intelligent life. I believe that there is the possibility for intelligent life to continue to develop all across the universe. But I think it's so spread out, it's going to be difficult for us to find and contact.
Well, Kurt, will you please come back again? Because this was so fascinating, and your knowledge is just out of this world. Ha, 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 ha.
Oh, well, I hope to have been a stellar guest.
No, you were. And I know the audience and the followers will definitely, I call him my co-host, will definitely love the information you have brought to us. I know on Twitter you're at Professor Kurt, but is there any other places people can follow you, find you, ask questions for you? Your YouTube channel?
I do have my YouTube channel, so just type in my name, Kurt Messick. The best way to do it is just type in like Kurt Messick, William Shatner, or Kurt Messick, Jerry Ryan, or something like that. And that'll take you, any of the Star Trek people, that'll take you to my channel, and you'll see my little interviews or shout outs or other things with the different celebrities. That channel also hosts all of my lectures for my classes.
Oh, great.
And so my introductory classes, my stellar and galactic astronomy class, I have the playlists of all of the lectures, so you can just do it and you don't have to pay me tuition or anything.
Right.
I'm on Facebook as well. I'm pretty accessible all over social media. So yeah, find me, friend me, love me, send me money.
Send me money. My Venmo is.
I don't have a Venmo. I need to correct.
Well, you can send it to me, and then I'll give him a portion of it. So.
I do have Amazon wish lists.
Right. Well, thank you so much. I really appreciate it. And for everybody out there, I'm sure they loved hearing your knowledge. And please come back again. I appreciate it.
Sure. Thanks for having me.
Of course. And so don't go anywhere, but I'm Tony Sweet. Please make sure you follow us, find us, and subscribe, leave comments, and watch Bonnie Burkert on Wednesday at 3 o'clock, the Truth Be Told Transformation. You have Robert Hensley on Monday at 3 o'clock. We have the Minuteman Report, and of course me every Friday right here on Truth Be Told YouTube channel. So until next time, I'm Tony Sweet. Take care of yourself. This has been another episode of Truth Be Told. Thank you so much for watching. Recorded live at UBN Go Studios in Burbank, California. Join us on social media: Facebook, Truth Be Told Radio; Instagram, Truth Be Told Paranormal. Go to Truth Be Told Worldwide for more information on upcoming shows.